Hello students, in this video we'll see how the disk method can be extended to form the washer method when you're rotating a region about a line. So if we're given two functions, y equals f of x and y equals g of x, consider the region between the curves. Rotate this about the x-axis. What will this give us? Here's the x-axis, here's the y-axis. Let's draw our functions. So here's our function y equals f of x. Let's say here's our function y equals g of x. And we're going to form, say between 2 points B and A, the region when I rotate this area about the x-axis. And so what we're going to get is we're going to get a region that if we close it off, that will have a shape that has an open area in it. And so what this region will look like is you'll have a region up here, down over here, and then the mirror image down over here. So we'll have this, and this, this, and this. And so both of those components are part of my region now. So we'll have this double-shaped volume to consider. So now what we'll do is we'll say, OK, to find this volume, what I can really do is I can find the volume generated by rotating this function around the x-axis, and then subtract off the volume generated by this second function over here. So what we'll do is we'll say that our volume is going to be pi, the integral from a to b, of this function f of x squared minus g of x squared dx. And so what we really have over here is, to write this in a different way, this is pi, the integral from a to b of f of x quantity squared dx. That would be what I would get if I just rotated f of x about the x-axis. But I don't want that whole volume. I want to punch out the volume that's cut out by g. So I need to subtract off the volume that g would generate if you rotated it about the x-axis. And this will give us, these will no longer be disks, but you're taking a disk and then you're punching out the center of the disk. So you start off with this disk from the f of x curve. There's your disk from the f of x curve. And then you're going to subtract off the disk from the g of x curve. So the shape you're going to get is you're going to get these sorts of cross-sections. And these cross-sections you're going to get are called washers that you see when you're building a piece of furniture. It's a washer. So this is called the washer method. And the washer method is really just the what? The washer method is really just the disk method minus the disk method. So a big disk minus a small disk. So big disk minus small disk gives you the washer method. So let's see an example of this. But it's important to realize that when you hear washer method, disk method, they're basically the same method. The washer method is just using the disk method twice and subtracting the top function's disk method from the bottom function's disk method. Let's see an example. Let's find the volume generated by rotating the region between y equals x and y equals x squared about the x-axis. Okay? Again, we'll use the washer method. The washer method tells you the volume is going to be pi, the integral from, we have to get a sense of what this region looks like. So to see what this region looks like, There's my x-axis, there's my y-axis, there's y equals x, that's a straight line. And y equals x squared is underneath that straight line when x is less than 1. So we're going to integrate from 0 to 1. Those are where my two functions intersect. When x is equal to 0, this is 0, and this is 0. When x is equal to 1, this is 1, and this is 1. So they intersect at 0 and 1. Those are my limits of integration. Then we do the top function. Remember now, between 0 and 1, the top function is x, not x squared. So it's the top function, so it's going to be x squared, minus the bottom function, x squared dx. So this will be pi, the integral from 0 to 1 of x squared minus x to the 4th power dx. So if we check this, this will be pi. The first thing, x squared, will integrate to a third. The second thing, x to the 4th, will integrate to a fifth. So I have a fifth minus a third minus a fifth. That's going to be a 2 over 15. So I get 2 pi over 15 is the volume that you get when you take this region over here, this sort of banana-looking region, and you rotate it about the x-axis. Thank you very much.